so I'm just giving another example for the AP transformations part. This is an example of a root function. So whenever you see the root, you have to look at the parent function, which is just y equals root of x. So we're going to take a look at this function here. We normally use x values of -2, -1, 0, 1, and 2. However, if you try to do the root of a negative, it doesn't exist. So you have to start with x equals 0. So if we do the root of 0, it's equal to 0. We can keep going here with 1. The root of 1 is equal to 1. Now here's the thing. If you try to do the root of 2, it's not going to be wrong. The root of 2 is approximately 1.41. However, you want to use whole numbers so that you get a better picture of what's happening. So I'm just going to take this one away. And I'm going to try to find the next whole number for x that gives me a whole number for y. So if I do the square root of 3, that doesn't happen. However, the square root of 4 is 2. If I continue that process, the next x value would be 9. And if you do the square root of 9, it equals 3. That would be more than enough to see kind of what's going on in your graph, but we're going to continue here to x equals 16, and the root of 16 is equal to 4. So now we're going to move on to transforming this parent function to the child function, but we need to figure out what our a, k, d, and c values are. So I'm just going to take a look at the a value, which is located in front of my root function here. Okay, if you take a look at the original equation that I gave you before, a reminder that this got fixed. So it's a, f, remember, it means that it's for any transformation of any function. Then we've got the k, the x minus d in brackets, close the square brackets, and then finally plus c at the end. So again, the a is the number that's in front of any function. So that's this guy, and since it's visible, a equals 1. There's not much we can do with a equals 1, because if you compare it to the parent function, you'll notice that here a is also equal to 1, which means there's no transformation for the a. So there's no vertical stretch, there's no vertical compression, there's no reflection either. So you can just leave this one as is. We move on to the k value. Now, just a reminder that your k value needs to be found after you've factored out the k. And I haven't done that quite yet. So I'm just going to go up here, and I'm going to factor out that 3, which means to divide both terms inside the root by 3. So we're left here with x minus 3, and then don't forget the plus 8 at the end. The k value actually doesn't change. It's still 3. Okay. So it doesn't really matter here. It'll matter for the d value, but you still need to do the work in order to get these questions right. So k is equal to 3. However, anything that transforms horizontal numbers is going to be different. So it's not a horizontal stretch. It's actually a horizontal compression, because we need to take the reciprocal of 3. And the reciprocal of 3 is 1 over 3. So this is actually a horizontal compression by a factor of 1 over 3. And again, that's just because you have to take the reciprocal. Now we move on to the d value. A reminder to use your d value from the factored equation. So that's from up here. And it looks like up here, it looks like it's -3. But again, this is a horizontal transformation, and it's always different. So my d value is actually equal to +3. And that means it's a horizontal translation. And this time it's going to be of 3 units to the right. Okay. And if you're not sure, you really should go use Desmos and check it. So I'm just going to go in Desmos and type this in. I also want to make sure that my factored equation is correct. So I have y equals the root of 3x minus 9. And I have a plus 8 on the outside, so don't forget to use your arrows, plus 8. Okay, so there's the child function not factored. I'm going to type in the factored equation, 3 bracket x minus 3. Forgot to put the root. 3 bracket x minus 3, close the bracket. I need to go on the outside to put the plus 8. I don't know why there's a 3 in the front. We're just going to delete that. There we go. So we know that these two equations are the same, and that means that I factored it properly. So I need to kind of look at this. The original root function looks like this. Okay, it's the green one at the bottom. So it does show that it went up by 8 and went over to the right by 3. You can tell. You can see from 0, 0, it went up to 8, and then it went to the right by 3. So that's what you should be careful when you're writing your transformations down. If you're writing that it's going to the left, that means you're not using Desmos to check. And then finally, we have a C value, and the C value is equal to positive 8, which is a vertical translation, and that's of 8 units up. Okay, so anything vertical remains the same. Anything horizontal, you need to think twice. So that means that we're going to transform our parent function by adding 8 to all of my y values. Now you notice that 8 equals 1. If I multiply every y value by 1, it won't make a difference. 0 times 1 is 0. 1 times 1 is 1. So that's why there's no transformations that are applied. However, the vertical translation of 8 units up means that you need to add 8 to all of your y values. Now everything horizontal affects the x's. Okay, so that's in the middle here. That's my x sandwich. Okay, so I have to multiply everything by not 3, by 1 over 3. And a reminder to put these numbers on the right. And then a reminder that there is a horizontal translation of 3 to the right. So we also need to do plus 3 for all of these x values. So from here, all we have to do is use our calculator. 0 times 1 over 3 is 0. And then 0 plus 3 is 3. 1 times 1 over 3 is 1 over 3. 1 over 3 plus 3 is 10 over 3. 4 times 1 over 3 is 4 over 3. Plus 3. I'm hoping that you're doing this with me and pausing if I'm going too quickly. 9 times 1 over 3 is actually 3, and 3 plus 3 is 6. 16 times 1 over 3 is 16 over 3. 16 over 3 plus 3 is 25 over 3. And then we're on to our y values. 0 plus 8 is 8. Then we have 9, then 10, 11, and then finally 12. So this is what we're graphing. Okay, in case you're wondering what we graph, this is the new table of values that we need to graph. So we're just going to go ahead and draw that. I might have to do it on the other page. Just don't have enough room here. I don't think we have enough room. So I'm going to go over here and just make a nice big graph. Okay. You can scale this however you want, but I prefer to scale these by ones. Just make sure that you're telling me how you're scaling, and that you label your x-axis and your y-axis. And here's positive 5, okay? So make sure that you're scaling this properly, and let's go ahead and graph this. So at x equals 3, it's going to be 8. 5, 6, 7, 8. When we have 10 over 3, we're at... For 10 over 3, it's 3.3, and then it's 3.39, 9, so 5, 6, 7, 8, 9, and then the next one, sorry, just trying to look at my picture here, is 13 over 3, and that's 4.3, so at 4.3, then 10. Okay, 1, 2, 3, 4.3. 5, 6, 7, 8, 9, 10. And then 6, 11. 5, 6, 7, 8, 9, 10. 11. And then 25 over 3 is 8.3. 8. And 12. So right up here. So you can see here that my root function, again, got moved to the right by 3 and then up by 8. So just label your equation with either the factored one or the non-factored one, it doesn't matter. And that's it.